Proportions. What is a proportion? We are going to use this often this year, so let's write down the definition of what is a proportion. So a proportion is an equation. A proportion is an equation stating two ratios are equal. So a proportion is an equation stating two ratios are equal. What's a ratio? It's really just a fraction. So a proportion is really just two equal fractions. Let's write that. Two equal fractions. So if the directions say use a proportion, you need to use two equal fractions. You need to. There needs to be an equal sign. There needs to be two fractions. So what does it look like? If it was all numbers, it would look like something, boom, two equal fractions. They are equal. 2 6 equals 1/3. If we have letters, you could have variables, and you could set up something like this. Now, there's something cool about two equal fractions, and we're going to write that here. So when two fractions are equal, their cross products are equal. Cross products. So when two fractions are equal, their cross products are equal. What on earth is a cross product? Well, product is the answer when you multiply. Cross is going to be, they're going across. So let's actually take this top example here. So we know that 2 6 equals 1/3. That's true. Check out their cross product. So 2 times 3 is supposed to equal the other cross, 6 times 1. Does that actually work? 2 times 3, yes. 6 times 1, boom. And that works with any two equal fractions. I'll make up another one. Let's say we've got a half. What's equal to a half? I don't know, 10 over 20? That's a half. Now let's check. 1 times 20. Does that equal 2 times 10? And I think it does, right? 1 times 20 is 20. 2 times 10 is 20. That works. All right, so we are going to use that fact to solve proportions when we don't know one of the numbers. Okay, so let me try. Let's just go right to an example. So example 1. All right. Let's say you have 2 over 5 equals 6 over x. Okay. Now, there are many ways to solve this one, but let me show you how to use the cross products, okay? So, and I always do the cross with the variable first. So 2 times x is 2x, right? 5 times 6, so here's the other cross. If you want to draw an arrow or a line, some people circle it, whatever you want to do. You don't have to do anything. 5 times 6 is 30. So now we're solving an equation. How are you going to get x by itself here? Well, you have to undo this times 2 business. So what's the opposite of multiplying by 2? Dividing by 2. So you're going to do that to both sides. I know you did this last year. 2 divided by 2 is really 1. So 1x is just x. That's what you wanted. 30 divided by 2 is 15. And that is your answer. All right, so that's how you're going to use cross products. It works every time. And the variable could be in any of these 4 spots. So let's actually try another one and put the variable in a different spot. Let's try 4 over n equals 15 over 180. Okay, so let's start with the cross with the variable. So 15 times n is 15n. 4 times 180, and we can use our calculator. I'm getting mine right now. 4 times 180 is 720. Okay, now to get the variable by itself, we're going to divide by the 15. 720 divided by 15 looks like is 48. So there's your answer for that one. Nice. Seems like you're getting the hang of it. We'll try a couple more. We'll put the variable in a different spot just to prove the variable could be anywhere. So let's say 10 over 16 equals t over 20. Let's try that one. All right, so we've got 16 times t, 16t, 10 times 20, 200. How do you get the variable by itself? You're going to divide by the 16. Type it in your calculator. 200 divided by 16 looks like 12.5. All right, good. Let's try one more. How about y over 35 equals 15 over 14? All right, we'll pause and you guys can try that one. All right, here we go. So 14y, 35 times 15 is 525. Divide by the 14, and we get 37.5. Nice. Okay, good. So solving the proportions, it seems like you're getting the hang of it. Now, what we're going to get for homework is actually a word problem. So you have to set up the proportion. All right, you have to set it up, which means you have to set up 2 equal fractions and then solve it like you were just doing. So let me just throw a word problem up here. Let's see, I've got one right here. All right, so it says, after 2 hours, the air temperature had risen 7 degrees. Write and solve a proportion. So they're telling you how you have to do it to find the amount of time it will take at this rate for the temperature to rise an additional 13 degrees, round to the nearest tenth. All right, here's what I want you to do. I want you to make what I call a T-chart. Looks like a T. And what you're going to do is you're going to put the 2 different units at the top. So what is this problem talking about? It's talking about hours and degrees, right? So let's do hours and degrees. Okay. Then in the chart, you're going to put together what goes together in the problem. So here it says 2 hours goes with the 7 degrees. So I'm going to line those up. 2 hours is with 7. Okay. The 13 degrees, make sure you put it under degrees. We don't know how many hours that's going to take, so we're going to put a variable there. Now, we're going to turn this chart into a proportion. All right, it's almost like you're going to take a picture, or whatever that noise is, and you're going to make it a proportion. So I'm putting 2 over x because 2 is over x. I need the equal sign, and 7 over 13. So you need that setup. You can't start doing your crossing and stuff in the chart. That is not really, this is a setup. This isn't really true math over here. This is the math that I need to see. right? Especially when it says use a proportion. That is a proportion. Two equal fractions. All right, so let's solve it. 7 times x is 7x. 2 times 13 is 26. We're going to divide by 7. And let's see what that is. 26 divided by 7. Here's what I got. 3.714, and the problem said round to the nearest tenth. So that's a 3.71. So I'm going to round it to here. It's going to stay a 7 or go up to an 8? Well, since that's a 1, that's going to stay a 7. This would have to be a 5 or more to boost it up, right? So 3.7, and let's put what it was. Is that the hours or the degrees? Either go back to the words and figure it out, or look in your chart. Where was our x? It was under hours, so that's what we're going to label it. All right? Okay. Good job, guys.